Okay, so good day, guys. So welcome again in our new session. So I hope, guys, hope all of you are doing well, doing good, doing great, and it's a good day. Okay, so let's start our lesson. So our lesson, as you can see, is it says kinematics. Okay, so the question is, what, sir, is kinematics? Okay, so when we talk about kinematics, so maybe you're wondering what is kinematics, or some of you are saying it is a branch of science. Yes, it is a branch of science. Yes, it is a branch of science. But when we talk about kinematics, it talks about something specifically like let's go to the next slide. Like, so what is it? What is it? Kinematics is what? Kinematics is, yes, it is a branch of mechanics that deals basically with motion. So when you talk about motion, we have some of you will say an object performs motion. An object performs motion uh, if it is change it, if it has a change in position, if it has a change in direction, or it occurs distance. Okay, so when we talk about uh, motion, yes, it is just basically having velocity, having acceleration, but it is not just like that. So motion is not only determined by the difference in distance or incurred distance, but also by the velocity and acceleration. So, guys, so an object performs motion if it occurs distance or incurred distance. Okay, so when it incurred distance, an object performs motion. For example, this finger, if it moves like this, yes, it incurred some distance. So that distance is not that big, or not that uh, very obvious, but the finger still performs or incurred some distance, and that also change in position. So when we talk about motion, an object should and will always change its position. Okay, so not just having a distance, but also have an acceleration and velocity. So acceleration is defined as how fast or how quick an object moves. For example, let's say a runner can reach a top speed of uh, 50 kilometers per hour, but how can he or she can attain that 50 kilometers per hour? So it is gradually speeding up, attaining speed from 0 to 50. Okay, so that is the acceleration. It is defined as how fast are you getting from 0 to a certain velocity. That is the acceleration. When it comes to velocity, it is your speed. It is how fast you can get from one point to another at a given time. So velocity is uh, incurring distance per unit time. So the question there is when you ask for velocity, it is how fast can you get from one point to another. That's why it is measured in meters per second or kilometers per hour. How fast can you get to one point to another in a given time? So that is velocity. Okay. So we have here velocity, which is measured in meters per second. The basic formula for velocity is v is equals to distance over time. Distance has a unit of meters, and time has a unit of seconds. That's why we have the unit of meters per second. Okay, so again, velocity v is equivalent to distance over time. Distance over time. That's why I said a while ago that velocity is measured from one point to another at a given distance. At a given time, uh, if you're going to reach one point to another. Okay. So next is we have the acceleration, which is measured in meters per second square. Okay, so meter per second square. We have a formula of A is equals to V2 minus V1 all over time. So, sir, why are you having two velocities and the distance only has one? Okay, so every distance you cover starts from zero. Okay, every distance you cover starts from zero, and everything that you incurred is measured from zero. Okay, so for velocity. But for the acceleration, we can always start from zero, but it varies from one point to another. What if you're just going to measure? You're going to measure. You're going to measure uh, acceleration from 10 to 15. So 10 to 15. So you have 10 meters per second to 15 meters per second. So that is different from 0 to 15 and 0 to 10. So the acceleration has uh, has its starting point to its peak, or what do you want to get. So that is acceleration. So we have here v2 minus v1, so you can compute or you can get our acceleration from a higher point, or a higher what do you call this one, so starting and ending. So we were going to start at the end minus the starting. Okay, so that is our acceleration, and we have a unit of meters per second square. So as you can see, the velocity has a unit of meters per second, while our time has a unit of seconds. So combining those two, we have meter per second, and that 2 second from our velocity and our time. When you combine it, that will result to meter per second square. Okay? So I hope it's clear, guys. So let's have an example here. A race car driver starts a time trial before the race starts. So he drove the car from 0 kilometers per hour to 120 kilometers per hour in just 3.75 seconds. So compute for the acceleration of the car that the driver is riding. So as you can see, guys, we have here a race car. So it's a little bit fast, 0 to 120 for 3.75 seconds. So it's not a joke having a car that is running from 0 to 120 in 3.75 seconds. So most of the cars that has 3.75 seconds, normally a Hyundai or a Honda has a 4 seconds up to reach 120 kilometers in a straight line. Okay. So, but this it is a 120 in 3.75 seconds. Okay. So we have here a given of velocity 1, which is 0 kilometers per hour, velocity 2 of 120 kilometers per hour, and a time of 3.75 seconds. So using this, we have a formula of A is equals to V2 minus V1. Our starting velocity and the end velocity are both being used here. So but we're going to get the difference of our V2 minus V1. Okay, so the next is we're going to substitute the values. Our V2, or our end velocity is 120, and our starting velocity is 0 with a time of 3.75 seconds. So guys, as you can see, our 120 and 0 here is in kilometers per hour. Okay, so if it is in kilometers per hour and our time is in 3.75 seconds, our base unit for our acceleration is meters per second square. We're just going to convert them in meters per second. So as you can see, guys, we have here 1,000 for 1,000 meters and 3,600 for seconds. That's why we're going to convert kilometers per hour to meters per second. So multiply those two, we will get the result of our acceleration of 8.89 meters per second square. Okay? So, did you get this one, guys? This is the basic computation for our acceleration. So as you can see, we have acceleration, velocity 2 minus velocity 1. So always go for our end velocity minus the starting velocity. Okay? So let's move on to the next topic of our kinematics. So kinematics has a way of determining velocity, acceleration, and distance and time and its relationships. Okay, so we have here graphical representation of motion, which is the method to determine motion by using graph as its medium. So as you can see, we will be dealing with graphs. So I hope guys that you're prepared in dealing with graph. So first off, it is the best tool. Yes, yes, it's the best tool to distinguish the relationship of acceleration, velocity, and displacement. So as you can see, guys, it is highlighted. The acceleration, the velocity, and displacement versus time. So all of those three will be used separately, but the time will always be constant. So it is the best tool to distinguish the relationship of acceleration, velocity, and displacement to time in a movement or motion of an object. So there's no point in getting what I'm saying if I'm not showing you what kind of graph we have. Okay, so what is the relationship between acceleration, velocity, and displacement to time? Okay, so we have different types of graphs. So as you can remember, I told you that there is a relationship between the distance, the acceleration, and the velocity to time. So we will be using those three separately, and all of them includes time. So first off, we have d versus t, which means distance versus time. So here we have a graph of our d versus t graph. So d means distance, t means time. So all those three, distance, acceleration, and velocity, will always be in the y-axis. Okay, it will always be in the y-axis, and the time will always be in, yes, correct. It is in the x-axis. Okay, so next is we have the v versus t graph. So that means velocity versus time. Same time, it is always in the x-axis, and velocity was changed from distance. So they are being used separately, but still we're determining the relationship of distance versus time and velocity versus time. So wait a second, guys. Okay, so moving on. The last graph that we have is the a versus t, or the acceleration versus time. So as you can see here, our distance velocity was changed to acceleration, but the time is still in constant position, which is in the x-axis. The components at the y-axis was always changed, but as you can see, our time is always constant because time is always moving forward, whether you have acceleration, whether you have velocity, whether you have distance. Okay, our time will always be constantly moving even without those three, but those three can be left alone, and it will just stay as acceleration, distance, and velocity. That's why it is placed in the y-axis. Okay, so we're not just dealing with the types of graph, okay, but we're also dealing with interpreting graph. So sir, how are we going to interpret graph? So you're just going to interpret something like this. So let's have an example here. So yeah. So how are you going to interpret this velocity versus time graph? So maybe you're just saying as the velocity rises, or the velocity increases, time increases. Yes, it's also correct. It's correct. It's correct. Some of you will say the velocity is constantly moving or increasing. It's also correct. So you can interpret graphs the way you see it, the way it is being presented in our graph. So maybe you see this graph as decline, but I can assure you that is the wrong interpretation. A decline, as you can see, the arrow is straightening up. So you will interpret the graph the way it is presented. Okay, it's not the way you see it. It's not the way you see it. You see it. It is the decline, but it is not in. It is not in the presentation. It is an inclining velocity. Okay, from zero to a certain point. As you can see, it is still an arrowhead, which means it is still rising. Okay, so that is how you interpret this graph, velocity versus time. Okay. So let's try this another one. So we have here, yes, acceleration versus time graph. Okay, so we're talking about decline a while ago. So this declined acceleration is being presented to you. So meaning our acceleration is on a decline. As the acceleration goes down, our time still moves forward. So as you can see, our acceleration is nearing to zero, which means this is a deceleration or a negative acceleration. Okay? And lastly, for our example, is we have here a distance. Oh, it's a straight line. It's just a straight line. So what does that mean? Okay. So when we talk about this straight line from the distance, it is not on the zero, but it has a value from our distance. So maybe our graph says that at a certain point, our car or our object is performing rest. So, sir, why is it performing rest? It has a constant distance. Okay, it is not zero. It has a constant distance. It occurred a distance at some point in time, but at as the object reached that distance, it is constantly at that distance and it's not moving ever since. It is not incurring distance anymore. It's not having distance going back. It's not moving forward, not going back. Still, it is in the same distance at a certain time. So you see, there is four stripes or four pins that our distance has passed. Okay, so it is not moved since, that's why this is measured or this is read as distance or the object is at rest. Okay. So let's try this one, guys. Okay. So we have here a velocity versus time graph. So I want you guys to try to interpret this graph. Okay. So please interpret this one, guys. Yeah. Okay. So here is our velocity. So guys, try to please try to interpret this one. Okay, so I'll be giving you guys time. Please. Okay, so if you're interpreting this one that the velocity is in constant it is in constant motion throughout the time, then you are correct. Because our velocity is constantly moving. As you can see, it is not on the 0 point. It has a point from zero to a certain velocity. Okay. So our velocity or our object is constantly moving at a constant speed. Okay. As time passes by, our object is moving at a constant speed. So how about this one, guys? How about this one? Okay. So I'll be giving you guys time to think about what is the graph or the what is the what do you call this one? What is the interpretation for this graph? Okay. Okay. So as you can see, our object is at rest, so it doesn't move since from the start. So it's at the distance measured in zero, and it hasn't moved since. Okay, so that is also an object at rest. Okay, so lastly, we have the acceleration versus the time graph, and our object is like this. So think about it. Think about for quite some time, and I'll get back to you guys. Okay, so have you thought about it, guys? Acceleration versus time. So our acceleration here is in constant acceleration. So it is a constantly in a point, like let's say it's in 5,000 RPM, rotation per minute, and it is in constant for that for a period of time. Okay, so our acceleration is uh, constantly moving. Our object is constantly moving, accelerating at a constant point, and the time also passes by. Okay, so let's go back to our types of graph, which is the acceleration versus time. So now we're going to solve this graph. So in order for us to solve, we will be using two methods. Okay, so the first one is the point slope form, and the next one is the area formula. Also, it's just two, the point slope form. So, sir, what's point slope form? Maybe you know this one, guys. This is just basic. This is basic math. I know you know this one. Point slope form and area formula. So, sir, what is the area formula? So, we will be tackling that after we pass through this. Okay. So let's have an example. So it is just right that we will be learning from example instead I'm just talking here, talk and talk and talk, and you just don't know what is this example about. Okay, so this example is for you to enhance your learning and to learn from the example itself. Okay, so for this example, we have a velocity versus time graph. So as you can see from our table, so we have velocity meter per second, and we have a time in seconds. So we have point A, we have point B, and we have point C. So we have velocity from point A as 10, and point B as 20, and point C is 30. And for our time, we have 5, 10, and 15 for A, B, and C respectively. Okay, so what are we going to do to that point A, B, and C, sir? So we're going to plot this one. So this is point A, this is point B, yes, and we have point C. Okay, so those are the 3 points that is plotted in our graph. Okay, and we're just going to connect those lines. Okay, so it is just connect the dots. It's a traditional connect the dots, but we can only connect those dots after we plot in our graph. Okay, so after plotting, let's try to find this one. So using point slope form, find the acceleration of point A and B. So it is clearly stated in our graph that velocity versus time graph, when point slope form was used, we can find the acceleration. Okay. Using the point slope form, we can find the acceleration. It is clearly stated here. Using point slope form, find the acceleration of point A and B. So our point slope form has a formula of acceleration is equivalent to rise over run. So this is just for velocity versus time graph, guys. Velocity versus time graph. We can get the acceleration using point slope form. So we have here the rise, which is our velocity. That is our rise. And we have our run, which is our time. Okay, so the rise is our velocity and the run is our time. Okay. So we have here formula of V2 minus V1 all over T2 minus T1. Okay? V2 minus V1 all over T2 minus T1. So guys, which one is our V2 based on our graph? Is it A or is it B? Okay? Which one is our V2? Is it A or is it B? Which one is our V1? Is it A or is it B? Okay? So our rise here is our velocity and our V2 or our point 2 is our B. Okay? B, and our V1 is point A. Okay? So same goes for our T2 and T1. Our T2 is B and our T1 is A. Okay, so rise over run. So we have here still the rise over run. Let's move on to substituting the values that we have. So our velocity is measured in meters per second while our time is measured in seconds. So don't forget about that, guys. Okay. So substituting the values, we have the value of our V2, which is 20. So that is point B. We have the value of our rise at A, V1, which is in 10. Okay? And we have the time 2, which is 10 seconds for point B and 5 seconds for point A. Okay? So, we can get the value of our acceleration as 2 meters per second square. So our object is accelerating 2 meters per second square based on our graph. So as you can see, it is clear that for every 5 seconds, for every second, our time has been doubled. Our velocity has been doubled. Okay, so 5, 10, 10, 20, and 15, 30. Okay? So that is how you get the acceleration using the point slope form. Okay? So next is using area formula, find the distance covered by points A and B. Okay, so distance covered by points A and B. So as you can see, guys, using the area formula na. A while ago, we're using the point slope form. Point slope form, we get the acceleration. By using area formula, we get the distance by points A and B in our velocity versus time graph. So as you can see, guys, we are using the point slope form in our velocity versus time graph, and we're also using the area formula for our velocity versus time graph. Okay, so let's proceed. So note, area formula may vary. Okay, so it is not just always the same, but it is very basic. So you will see that it is easy to understand what the note are saying. Area formula may vary. So sir, why is it may vary? Okay, so let's proceed. So as you can see, here we have point A and we have point B. Okay, so that is our points. Points A and B. So this as a zoomed out graph, zoomed out graph. we have point A and we have point B. Still the same. We have the points A and point B here. So we're not going to take out those lines going up from 5 and 10. Okay, so because we're going to have as you can see, we can get a triangle there. So at point 10, if you put an imaginary line, an imaginary horizontal line, from 10, it passed through point A. We can get a triangle, shape. Okay, we can get a triangle shape from point A and B. So we have the hypotenuse, which is our line that passes from point 0 to point A to point B, and that 10 mark in our velocity. If you put an imaginary line, we can get a area, or the area of the triangle. Okay, so we have the formula of our triangle, area of our triangle, which is 1/2 base times height. 1/2 base times height. So, sir, which one is our base? So, as you can see here, we have here the base, which is our time. That is our base. And we have our height as the velocity. So that is how are we going to view this formula. Area of our triangle is 1/2 base times height. So it is very basic, guys. Very basic math that the triangle has a unit, or has a formula of base 1/2 base times height. So proceeding here, we can get our area of triangle, which is 1/2 base times height, which is 1/2 10 minus 5, which is our time. 10 minus 5 multiplied to 20 minus 10, which is our height from the velocity side. Okay. From our time side, that is 10 minus 5. Okay, so with that, we can get the value of our area of the triangle, which is 25. So let's try to solve this one, guys. So we have here uh, 1/2 times our base, which is 10 minus 5, and our height, which is 20 minus 10. So we can get the value of our triangle, or what do you call this one? Our velocity, or our distance covered, which is 25. So, sir, how did you arrive the unit at the unit of meters? Okay, so guys, as you can see, the velocity has a unit of uh, meter per second. The velocity has a unit of meter per second. Okay, and the unit of time is in seconds. When you multiply those two, meter per second and second, what will going to happen? You can cancel out the second. Okay, and that the meter will be remained, and that is you're going to use as the unit for distance. Okay? Okay. So not just the area of our triangle. You can see this point, the red box is hollow. It is hollow. So that's why we're going to use another another shape for that, which is square. Okay, so we're going to fill that also. It's not just being left out. So as you can see, it is a trapezoid. That the shape is in trapezoid shape, right? The half of it is triangle, and the other half is a square. The other side is triangle, and the other side is square. So we're going to get the area of the square also, the base and the height. Okay, the base and the height. So the base is also our time, and our height is also the velocity. So substituting the values, base is 10 minus 5, and the height is 20 minus 10. So let's try to solve this again. So we have here the base of our height, which is okay, 10 minus 5 and 20 minus 10. So we get the value of our graph, or our rectangle, is 50 meters. Okay, so we have the value of our square or our rectangle as 50 meters. So, sir, how did you arrive also at the unit of meters? So, guys, as you can see, base is in time, but the base is our time and the height is our velocity. So, base as has a unit of seconds and the height or velocity has a unit of meter per second. Multiply those 2 meter per second and multiply the time, we can cancel out the time. We can cancel out the second, and then we will be left with the unit of meter, which is the which will have the answer of 50 meters. Okay. So for that we can combine those two because we're getting the total area. We're getting the total distance in our graph. Okay. So we have the total area, which is the area of the triangle plus the area of the square. We have the area of the triangle, which is 25 meters, and the area of the rectangle, which is 50. Combine those two, the total area will be 75 meters. Okay, 75 meters. Okay, so that's it. Try to solve this one, guys. Okay, so on your own, try to graph this one. Try to graph, and I'll be calling out someone to answer. Okay, so what will you get if you solve points C and D using point slope form and area formula? Okay? So, okay guys, note, give complete solution. I'll be giving you guys time to solve this one on your own. Please guys, please solve this one on your own. Okay, so hint, your answers should be based on the units. Okay, so what will you get in our point slope form and the area formula? Okay. Okay, so please, this one guys, please try this on your own. So I will be back after quite some time. Please guys, please uh, try to graph, and I'll be calling someone to give the answer. Okay. Okay, so let's see if you totally get this one. Okay, so I'll be back, guys. So in performing or plotting the graph, always make sure that you know the type of graph that you will be using. Okay. So make sure you know the graph that you will be using. We have here a while ago we're using the velocity versus time graph. Now we will be using the distance versus time graph. So I just gave you this one, guys. I just gave you this one. I gave it away. Okay. So we have the velocity versus time graph a while ago. Now we will be using the distance versus time. Okay. So guys, please plot this one, and I'll be asking someone. Okay. I'll be back, guys. So, okay guys, maybe you saw the image that I showed a while ago. So, okay, so if you draw the graph like this, then you're correct. Okay, so this is the image, or this is the graph. This is the graph that is uh, being plotted. This is the graph that is being plotted in our graph. Okay, so we have our points A, B, C, and D, which is point A is in wait guys. Okay guys, so this is the graph that we're going to be plotted. So if you ever have plot this one like this one, then you're correct. Okay, so we have points A from 0, 0, point B from 5, 15, distance of 15 and the time of 5. And we have the same point which is 15 also for C and at 10 seconds. And lastly, we have 15 seconds and point of 25 meters. Okay? So this is how you going to plot this one, guys. Okay, so let's remove this one. Okay. So, yep. Okay. So, if you uh, plot that one, guys, so maybe you will already know the answer. So, for the answer, so what did you get, guys, in getting the answer for point slope form? You should have velocity of 2 meters per second. So you should get the velocity of 2 meters per second. So sir, how did that happen? Oh wait. My calculator is malfunctioning. Okay. Oh no, wait. Mm-hmm. Wait guys, wait. Okay, so we have here our calculator now. So, okay, so how did you get, or how did you arrive, sir, at our velocity of 2 meters per second? So, using the points C and D, we have the point slope form. We have the rise of our distance, which is 15 and 25. So, starting from our furthest point, which is our D, which is uh, Yep, wait. Wait. Okay. So 25 minus 15. So that is our point D. 25 minus 15. Point D, which is 25, and point C, which is 15. And for our time, which is 15 minus 10. Okay. So 15 minus 10. And that is our points for time for point D and point C. Okay? So getting that, solving for that, we have the answer of 2 meters per second. So that is how we get the answer for our point slope form. We get velocity. Okay, we get velocity. So sir, how about the next one? The area formula. So when we talk about the area formula, yeah, sorry to disappoint you guys, but we don't get anything there. Okay, so why didn't we get anything from the area formula? So basically, using the formula of the rectangle or the triangle, we will get the base times height. The base is our time and the height will be our distance. What will you get in our distance multiplied by time? None. You will not get any. Okay, so and basically when we talk about motion, we're just dealing with distance, velocity, acceleration, and time. Okay, we're just dealing with those four, and those four has a unit of, for velocity we have meter per second, for acceleration we have meter per second square, for distance we have meters, and for time we have seconds, and none of them are measured in meter second. That's why we cannot get anything from the area formula in this graph, which is in the distance versus time graph. So basically, when we talk about the distance versus time graph, we're just only getting the velocity, and it is through the point slope form. Okay? We're just getting the velocity using the point slope form in the distance versus time graph. Okay? So I hope guys you understand this well. And if you understand this very well, let's try to give it another shot. So on your own again, we have here points A, B, C, and D with the acceleration. We have the time of 3, 6, 9, 12 for points A, B, C, and D, and the acceleration of 15, 12, 9, and 6. Okay? So, what will you get if you solve points C and D using the A point slope form and B using the area formula? Okay, so again, give complete solution. And aside from that, your answer should be based on the units. That's why I said a while ago, your answer should be based on the units. So as you will see, what type of component we will get if we use the point slope form and the area formula. Okay, so let's uh, give you another time to answer this question. Okay. So, okay. So, yan guys. So, you see that we have here the picture of our graph for this second set. Okay, so if you get this, then you're probably correct also. Okay, so as you can see, we have here the green shaded area. We have here the area for our uh, points C and D. So we're getting the points for C and D. We have the area formula. Okay, so sir, paano po yun? Okay, so here's the answers. Okay, so for the answer for point slope form, we're not getting any. We're not getting any for this point C and D, point slope form, because we're not gonna get anything from meter per second square all over second. So that would be meter per second cube, and we don't have anything like that in our discussion. So that's why none of it will be there will be no answer for point slope form. But for our area formula, we will get the velocity. So the area formula, we will get the velocity. So with this, we have that yes, we have we're going to get the area for points C and D. We have the triangle and we have the rectangle. Okay, so that's it, guys. If you get this one, so if you get this one, then you're correct. Okay, so pag nakuha nyo yun, there will be a chance that your answer will be correct. So, sir, what is the velocity? Okay, so let's try to solve this one. Points C and D. Okay, so as you can see, it is clearly a deceleration, guys. It is a deceleration. So, sir, why is it deceleration? From point A, B, C, and D, we are declining. Okay, so we're on the decline. That's why it is deceleration. Okay, so let's try to solve for the velocity. Okay, so we have the triangle, which is the base times height. We have uh, base of 0.5. The base is our time, which is point of this is for the triangle part, guys. This is for the triangle part. We have 12 minus 9 for our time, and we have for our height we have 6 minus 9. Okay, so 6 minus 9. This is for the triangle part. So we have to add our rectangle part, which is our base. The base of our rectangle is, wait, okay, so we have the answer of negative 13.5 meters per second square. So as you can see, we have the negative answer that is completely correct since our acceleration is on the negative. Okay, so if you get a negative acceleration, that means you are on the decline, meaning you are slowing down. That is what we call deceleration. Okay? So 13.5 seconds. Okay, so we have there our base, which is 12 minus 9. 12 minus 9, and we have our height of 6 minus 9. As you can see, the point D is our height 2, or the outermost part, the end point of our points. Okay, and the starting point there is C. Okay, because that's what we're asking, the points C and D only. Okay, so do you have any questions, guys? So if you have questions, you may start answering now, as you may start asking them now, and I'm going to end this video, guys. So thank you for Thank you for listening. Thank you for bearing with me. And this has been kinematics for our lesson. And thank you guys. Bye.